join to form a bridge. That is the bridge of the nose here. Lacrimal bones. Two lacrimal bones, those green colored, shown behind the frontal process of maxilla. So those are some. Palatine bones, we know that form the posterior 1/3 of the hard palate that I have mentioned, and vomer is a plow-shaped bone here in the lower part of the nasal cavity, and forms the lower part of nasal septum. Now you see, this is the ethmoid, you must remember, and I mentioned a perpendicular plate is going downwards like this, right, inside the nasal cavity. Do you remember that? That's why it is forming the upper part of nasal septum. Nasal septum. And now you saw the vomer, which is forming the lower part of nasal septum, right? So what is happening actually, this is the perpendicular plate of ethmoid going downwards inside the nasal cavity like this, and this is the vomer. Make sense? So those two together forming the nasal septum, right? So that's the vomer. Okay. This is a nasal septum. First, let's see those two bones. You see the yellow that is coming from above. That is the perpendicular plate of ethmoid, this piece. And you see the one below, that is the vomer. And those two are forming the bony part of nasal septum, because nasal septum also has cartilaginous part. You'll see, if you hold your nose like this and move, you can move the nasal septum, right? You can move the nasal septum. That means what? It has cartilage too. Make sense? You can move the cartilage. You cannot move the bone because it is hard, right? So the front part of nasal septum is cartilaginous. Back part is bony. So bony part is formed by the perpendicular plate of ethmoid and vomer. That is the hard part. But the part you can move, that is the cartilage, hyaline cartilage. It is also called septal cartilage. Cartilage is the septum, nasal septum. Sometimes what happens, you know, this nasal septum bends to one side. It should be in the middle, right? It should be in the middle. But if that cartilage grows and enlarges, then what happens? It bends and can block one side of the nasal cavity. Make sense? And in that case, you have to do surgery to make the cartilage short, okay? To fix it. Okay, so those are the cranial and facial bones. Now we'll see the sinuses. Most of the sinuses are in the facial and cranial bones. So you can see here the important sinuses are, which one is the largest? Maxillary. Remember that? That's the largest sinus, right? Inside the maxillary bones. You also have seen the sinuses. What are these? Sinuses, right? Or air cells. These are very small and many, right? Maxillary is the largest one. One in each maxillary bone and largest. So we already have seen maxillary sinuses, ethmoidal sinuses. Inside the frontal bone, this is the frontal bone, you also have sinuses. Those are called frontal sinuses. And you remember the butterfly-shaped bone, sphenoid. Sphenoid also has sinuses, so called sphenoidal sinuses. So those are the important sinuses. Now if you see the red ones, the maxillary sinuses are the largest, okay? Inside the maxillary bones. Hyoid bone. Now we'll see other bones of the axial skeleton. You see this bone hanging in the upper part of the neck. That is the hyoid bone. Okay? This bone is called a lonely bone. Okay? Why it is called a lonely bone? Because nobody wants to include this bone in their group. Nobody wants to include him. Okay? So he is lonely. When we say cranial bones, we don't include him, right? When we say facial bones, did you include? No. When I say bones of the vertebral column, we include cervical vertebrae, thoracic vertebrae, lumbar vertebrae, right? We don't include him. When we talk about thoracic case bones, we say ribs, we don't include him. Make sense? So, nobody wants to include him. That's why it is called what? Lonely bone. Lonely bone. Another reason is it is not directly attached to any bone. No direct attachment. Now the question is then how it is staying there, right? If it is not attached to a bone, it is actually hanging here by ligaments and muscles. So it is not directly attached to or touched to any bone. No physical attachment. That is another reason it is called lonely bone. But this bone is very important because you see why this bone is located in the front. This is the only bone here. And you know, anterior neck muscles, right? These are anterior neck muscles. They are getting support from this bone because this is the only bone right here. So anterior neck muscles are supported by this bone. Make sense? Now, why anterior neck muscles are important? For swallowing the food, right? When you swallow, these muscles are very helpful, useful, right? So, few of these muscles help in speech, to move the mandible. So, to move the mandible, these anterior neck muscles are important. And they are supported by this bone. Make sense? So, it is important. If you see a hyoid, it has a body and two pairs of horns, not wings, two pairs of horns, lesser horns and greater horns, and a body. In sphenoid, you saw a body and two pairs of wings, greater wings and lesser wings. Anyway, so this is the hyoid. When you see this bone in your lap part, you see, make sure you see these things. Vertebral column. This is the vertebral column or spine. So, vertebral column, if you see from the top, you have in the neck part here, you have 7 cervical vertebrae. So, how many? Cervical, how many? Everybody? 7. So, which part of the body? Neck. So, C1 to C what? 7. Okay? So, this is C1, C2, C3, C4, C5, C6, C7. We indicate it by number from the top. 1, 2, 3, 4, 5, 6, 7. Then, this is the thoracic part of the body, you know that. So, in this part, you have thoracic vertebrae. How many? 12. So, T1 to T12. Okay, in the thoracic part. Then, this part is called the lumbar part. So, you have lumbar vertebrae. How many? 5. L1 to L5. 5 lumbar. Okay. So this is fit. triangular bone here. That is called what? Sacrum. Right? So sacrum is one. Actually, in infants, if you see in infants, sacrum is not one piece. 5 pieces of sacral vertebrae. They are separated, okay? 5 pieces of sacral vertebrae are what? Separated. Then they fuse together to form one large piece of bone that is called sacrum. Okay? In very early stage, they are not attached. That's why you see 5 sacral vertebrae separated, but later they get fused together to form one large triangular bone that is the sacrum. So, sacrum. Then you have coccyx, tail bones here below the sacrum. These are, you see here, this is the sacrum, and below the sacrum you have 3 to 5, the number varies, tiny pieces of bones. Those are called coccyx or coccygeal bones. Okay? 3 to 5 in number. So those are the bones of the vertebral column: cervical, thoracic, lumbar, sacrum, and coccyx. Now, the vertebrae are attached to each other by intervertebral discs. Inter means what? In between two, right? And these are the discs. Cartilaginous discs, right? So, intervertebral discs. Intervertebral disc has 2 parts. If you see an intervertebral disc, the outer part and inner part. The outer part is called annulus fibrosus. That's the outer part, outer ring. Annular means ring, you know the ring shaped. So that is the annulus, annular means ring, annulus fibrosus. Why fibrosus? Because this outer part or ring is formed by many fibers, fibrocartilage. You must remember fibrocartilage. Okay, that's why fibrosus, a ring of fibrocartilage. Make sense? Right? Makes sense, right? Annulus, ring, fibrosus, fibrocartilage. In the center part, you have soft jelly-like structure that is called nucleus. We know that nucleus usually refers to the center. So nucleus pulposus. Nucleus pulposus, which is soft tissue, jelly-like structure. So that's the structure of an intervertebral disc. You see, this is a longitudinal section like this. We cut like this. You see the inner part and the outer part. Nucleus pulposus, annulus fibrosus. Here, you see what happened. Sometimes, if excessive pressure is fallen on the intervertebral disc, excessive pressure is given, that can cause what? The inner soft part to push outwards, move outwards. So you see the intervertebral disc, portion of it may pop out, and that is called herniated disc or slit disc. Makes sense, right? Slit, pushed outwards. Hernia, the term, I don't know if you have heard this, hernia is the condition where a part of any structure moves from its normal position to abnormal position. That's the definition of hernia. Any portion of an organ moves from what? Normal to abnormal position in your body. Make sense? So if your eyeball comes out, I'll say herniated eye. Make sense? Herniated eye. If a part of intestine, okay, moves away from its normal position, okay, herniated intestine. Make sense? Have you heard inguinal hernia? That is very commonly heard, right? That's the spermatic cord. If that moves outwards, comes out from the, there is an inguinal canal. This is the inguinal canal. This is the spermatic cord, okay? It should be located inside that canal. Make sense? Now sometimes if someone carries too much weight, right, for a long time, it can happen gradually. That pressure can rip the wall of that canal, and that spermatic cord can come out like this, tearing the wall. Okay, so that is called what? Hernia. You see, movement of any structure from its normal to abnormal location or position inside the body is called hernia. So this is clearly herniated disc. The disc is pushed out. What happens, you see, this is the disc. If a part of it is pushed outwards like this, what is the problem? Problem is your spinal nerves come out like this. You see intervertebral foramen here. So this is spinal nerve that comes out like this from the spinal cord. Now, if this intervertebral disc is pushed backwards, what will happen? It will push the spinal nerve because it is just behind it. So that causes pain and can cause numbness, right? In that area where that particular spinal nerve is innervated. If it is innervated to your thigh, right, this area will be painful and numb. So that is the herniated or slit disc. Parts of a vertebrae. We know that vertebral column is a column formed by vertebrae, different groups of vertebrae, cervical, thoracic, lumbar. Now, also sacrum. So now, if you see the structure of a vertebrae, it has a body in the back, in the front. So this is the body in the front. And in the back, you see here, you have a number of structures, processes. So how many processes you have? 7 processes. 7 processes. Now let's see, what are those 7 processes, okay? This process, which is going backwards and downwards, this is called spinous process. So these are spinous processes. So each vertebrae has a spinous process. And 2 transverse processes going this way. Transverse processes. Okay? Spinous process is going backwards, straight, and 2 transverse processes sideways. Then superior articular and inferior articular processes. So look at this. This is the body of the vertebrae, and this is the spinous process going backwards, right? Like this, spinous process, and 2 are what? Transverse processes. Make sense? And also, there are 2 processes like this. When you see the vertebrae, look at this. 2 processes going upwards. Those are called what? Superior articular processes. Make sense? superior, and two are going downwards like this. Those are called what? Inferior articular processes. Make sense? So again, this is what? This part is the body, right? This is the body of the vertebrae. And this is what? Going backwards. What is this? Spinous, right? One. And two are going sideways like this. These are transverse. Two are going upwards. These are superior articular, right? And these are inferior articular. Is it clear? So those are the 7 processes. Now, what happens, you see, these are superior articular processes, right? Again, superior articular processes. So, this is superior articular process, one of these two. And the vertebrae above has inferior articular processes, right? So, they get attached like this. So, superior articular process of the vertebrae below attached to the inferior articular process of the vertebrae above. And that is the joint. Okay? And also, intervertebral disc is holding the body. So these are the intervertebral discs. They are holding the bodies together. So that's how the vertebrae are attached to each other. Superior and inferior articular processes like this, and the disc is holding the body. So that's all about a typical vertebrae. Typical means common type. Now, two vertebrae are called atypical. A means not or absent. So, atypical, different. Atypical. Which two? C1 and C2. This is C1 or atlas. C1 is also called an atlas. Why C1 is atlas? Because this is like a globe. We know the map globe. So this is a globe, and it is sitting on C1, uppermost vertebrae. So this is atlas. And this is the only vertebrae that doesn't have any body. So remember, if I give you C1 or atlas, how you can tell this is C1 or atlas? It doesn't have any body. No body, right? Only vertebrae. So easy. However, since it doesn't have a body, you see body is missing from this vertebrae. So what happens? The vertebral foramen is very large. You see the vertebral foramen is very large, like this, big. Because it doesn't have body here, right? So no body, large vertebral foramen, and two arches like this. This is one arch, this is another arch. Anterior and posterior arches. Posterior arch is bigger, anterior arch is smaller. Okay? So that is C1 or atlas. Make sure you see this when you do the lab part. Easy to identify those structures. C2 is also atypical, different. C2 is also called axis. So look at this. This is an axis. Why it is different? Because you see this is the body, and from the body a finger-like structure sticks upwards. That is called dense or odontoid process. No other vertebrae has that. So dense is a structure, it's like a finger like this, sticks upwards from the body. So if you see that, dense or also called odontoid process, same thing. This is C2 or axis. Now the question is why this bone is called axis. Look at me. This is C2, it has the dense like this, right? And this is C1 sitting on C2, right? So this is C1, this is C2, make sense? And C1 rolls like this, moves like this, around this. So that's why this is called axis. Okay? So atlas is C1, axis is C2, and you cervical vertebrae, this is a typical, like C3 to C7. All cervical vertebrae, if you see the spinous process, this is very easy. If you see the spinous process is divided or split, I mentioned you in the lab, you see spinous process, it is divided here, that is cervical. If you see the spinous process, now look at thoracic. If you see spinous process is long and pointed, it's not split, that is thoracic, long, pointed. If you see spinous process, look at this one now, it is very easy. If you see this one, it is short and flat, not pointed, the end is flat and broad, that's the lumbar. So split is cervical, long pointed is thoracic, and short, flat, that is what? Lumbar. Make sense? So if I give you three, which one is cervical, which one is thoracic, which one is lumbar, you should be able to identify that. And looking at the spinous process only, you can identify it. Okay? There are other features. Another thing is, in cervical, you have transverse foramina. Transverse foramen in the transverse process. Only cervical has transverse foramen in transverse process. These are transverse processes, transverse foramen. Only in cervical. So that is another way you can identify. Okay, so let's stop here. Just let's finish. Abnormal bending of the spine or vertebral column. Sometimes it is hereditary by birth, it can happen, or it could be the birth defect, or by accident. However, if you see the spine or vertebral column is bent like this, sideways, laterally, that is called scoliosis, the first one. So the person will be like this. Make sense? So that is what? Scoliosis. If you see the upper portion of the vertebral column, this is the upper part, right, of the spine, is curved like this. So this is the thoracic part, is curved like this. That is called kyphosis. Kyphosis. You remember the movie you watched probably, some of you, Hunchback of Notre Dame. So this is called hunchback, kyphosis, okay? It's a back part is like this. And scoliosis, lordosis. If the lower part of vertebral column, this part, you see, of the spine is pushed like this. If somebody pushes from the back like this, that is called lordosis, okay? So this is what? Scoliosis, right? This is kyphosis, right? And this is lordosis. So those are common type of abnormal bending or curvature of the vertebral column. Another clinical condition that is called spina bifida or spina bifida. Bifid or split, you know that term, right? You remember I told you split or bifid, end of the spinous process. So what can happen when the spinous process is formed? This is the spinous process, okay? You know that. Spinous process. Actually, what happens? Two pieces of bones come together and get fused to form the spinous process, like this. Look at me. Two pieces are formed separately and fused together to form what? A spinous process. Make sense? Now, if those two pieces never get fused, stay like this, that's the birth defect, right? What will happen? If, look at this, if this few spinous process are never fused, those two pieces, a gap will remain in the back because they are separated like this. A gap will remain here. And through that gap, the covering of the spinal cord, which is called meninges, or the covering together with the spinal cord can come out. Okay? So two things can happen through that gap here. The covering of the spinal cord can come out, which is not that dangerous because the spinal cord is still inside, right? But if the spinal cord also comes out, that is more, problematic, right? So spinal cord should not come out from the vertebral column. So two conditions. One is called meningomyelocele, which is more complicated because spinal cord also comes out through that gap. And meningocele is if only the covering comes out, so which can be fixed more easily. Okay. In meningomyelocele, since the spinal cord comes out, that can cause paralysis or other complications if any damage occurs in the spinal cord. Okay, so that's the spina bifida. So that's all about this part. So this lecture will help you to identify the bones in the lab.